Picture this. You are strapped into a sleek metal cart, slowly clanking up a near vertical track. Clack, clack, clack. The anticipation builds until you crest the peak, and suddenly, the world drops out from underneath you. You plummet downwards, hitting speeds that press you firmly against the back of your seat. But the real magic happens next. The track curves sharply upwards, launching you into a massive 360-degree loop. For a brief, heart-stopping moment at the very top of that loop, you are completely upside down. Gravity is pulling relentlessly at your body, screaming at you to fall straight down to the earth. Yet, your phone stays in your pocket, your glasses stay on your face, and most importantly, you stay firmly glued to your seat. It feels like an illusion, or maybe you just have incredibly strong shoulder restraints. But what if I told you that even if those restraints completely vanished in that exact second, you still wouldn't fall? Welcome back to the channel, Science Explorers. I'm your resident physics teacher, and today, we are diving into one of the most thrilling paradoxes in amusement park history. Why exactly does a roller coaster loop defy gravity? And what invisible force is keeping you safe when your world is flipped upside down? Let's find out. So let's hit the brakes for a second and ask the million-dollar question. Why? Why does gravity seem to take a coffee break just when you are hanging upside down, completely at the mercy of the universe? I promise you, gravity is still working just fine. In fact, it is pulling down on you as hard as it always does. The secret to your survival doesn't lie in turning off gravity, but rather in a beautiful, invisible dance between two fundamental concepts of physics: inertia and centripetal force. To really understand this, we need to talk about your body's deep, stubborn desire to just keep doing whatever it is currently doing. In physics, we call this stubbornness inertia. Sir Isaac Newton figured this out a few centuries ago with his first law of motion. It basically states that if you are moving, you want to keep moving in a perfectly straight line at the exact same speed forever, unless something physically forces you to stop or change direction. Imagine you are sitting in the passenger seat of a car, and the driver suddenly takes a sharp left turn. What happens to you? You feel like you are being thrown to the right side of the car, right? You smash against the door. But here's the mind-blowing truth. You aren't actually being thrown to the right at all. Your body is simply trying to keep moving in the straight line it was already traveling in. It is the car that is suddenly turning to the left, and the car door is basically slamming into you to drag you along for the ride. A roller coaster loop works on this exact same principle, just rotated vertically. When your roller coaster car approaches that massive loop, it is traveling at an incredibly high forward speed. Your body, completely fueled by inertia, wants to shoot straight forward like a rocket. But suddenly, the steel track curves upward. The track gets in your way. It physically forces your car, and therefore your body, to change direction and bend into a circular path. This brings us to the hero of our story: centripetal force. The word centripetal literally means center-seeking. Now, this is a crucial point where a lot of people get confused. Centripetal force is not some magical new force that appears out of nowhere. It is simply the name we give to any force, or combination of forces, that keeps an object moving in a circle, constantly pulling it toward the center of that circle. In the case of our roller coaster, the centripetal force is provided by the rigid metal track, pushing against the wheels of the cart, combined with gravity itself. Let's freeze time exactly when you are at the very top of the loop, completely upside down. At this exact second, gravity is pulling you down toward the earth. But remember your inertia. You are moving forward so ridiculously fast that your body wants to shoot horizontally out of the loop in a straight line. Because your forward speed is so immense, your body pushes hard against the seat of the roller coaster as you try to escape that circular path. In response, the seat pushes back down against you to keep you moving in the circle. And here is the kicker. That feeling of the seat pressing firmly against your body is exactly what your brain interprets as weight. So, even though you are upside down with gravity pulling you toward the ground, your intense forward momentum forces you to press so hard into your seat that you feel firmly planted. You don't fall because your forward speed is literally pinning you to the track. It is an invisible string, woven purely from velocity and curve geometry, guiding you safely through your wildest ride. Now that we have unlocked the secret of the roller coaster loop, let's play a little game of imagination. I want us to take this exact same physics principle, this beautiful partnership between inertia and centripetal force, and see what happens when we drastically change the scale. We are going to shrink it down to your backyard, and then blow it up to the size of a massive cosmic habitat. First, let's scale things down. Imagine standing on your lawn on a hot summer day, holding a plastic bucket attached to a strong rope. You fill that bucket right to the brim with water. Now, grab the rope and start swinging the bucket in a large vertical circle right next to your body. As the bucket arcs over your head, turning completely upside down, what happens to the water? If you are swinging it fast enough, the water stays perfectly inside the bucket. You stay completely dry. This is the roller coaster loop, happening right in the palm of your hand. The water inside the bucket has mass, and as you swing it, that water builds up forward velocity. When the bucket is upside down at the highest point of the circle, the water's inertia makes it want to shoot straight up into the sky. However, the plastic bottom of the bucket constantly gets in the way, intercepting the water and forcing it to follow the circular path. The bottom of the bucket is pushing against the water to keep it moving in a circle, and the water pushes back. But there is a catch, and it is something roller coaster engineers lose sleep over: critical velocity. What happens if you get tired and swing the bucket in slow motion? Gravity finally wins. The water's forward momentum is no longer strong enough to overcome the downward pull of the Earth, and you get a very wet, sudden shower. Roller coasters are precisely calculated to always exceed this critical velocity at the top of the loop, ensuring that the cart's desire to go straight is always significantly stronger than gravity's desire to pull it down. Now let's take this concept and zoom out, way, way out, into the cold vacuum of space. If you have ever watched astronauts floating aboard the International Space Station, it looks incredibly fun. But long-term exposure to zero gravity, or microgravity, is terrible for the human body. Without the constant resistance of weight, an astronaut's bones lose density, and their muscles begin to waste away. If humanity ever wants to travel to distant stars, or build permanent colonies in space, we need gravity. But how do you create gravity out of absolutely nothing? You build a giant roller coaster loop. Well, sort of. You build a rotating space station. Picture a gigantic, ring-shaped spacecraft. Much like the iconic ships you see in science fiction movies like Interstellar or 2001, A Space Odyssey. In the void of space, there is no up or down. But if you fire up the thrusters and make that massive ring spin, something magical happens on the inside. If you are an astronaut, standing on the inside edge of this spinning ring, your body naturally wants to float off in a straight line due to inertia. But the outer floor of the space station is curved, and because it is spinning, it is constantly moving up into your feet, pushing you toward the center of the ring. This continuous push from the floor, this massive scale centripetal force, creates a sensation that your brain interprets exactly like gravity. By simply spinning a giant metal donut in space, we can trick our bodies into feeling the exact same comforting weight we experience on Earth, proving that the physics keeping you safe on a carnival ride might just be the key to conquering the galaxy. We've talked about adrenaline-pumping amusement park rides and colossal futuristic space stations. But you absolutely do not need a thrill-seeker's ticket or a degree in astrophysics to experience the magic of centripetal force. In fact, this exact same physical principle is quietly working behind the scenes to keep you completely safe every single day, often during your very ordinary morning commute. Have you ever noticed that when you are driving on a major highway, the road isn't perfectly flat when you enter a sharp curve? Instead, the road is visibly tilted, or banked, upward on the outside edge. This is not an aesthetic choice or a mistake by the paving crew. It is a highly deliberate, life-saving application of physics. When your car travels at high speed around a curve, its inertia desperately wants it to continue moving in a straight line. If inertia won that battle, your car would skid right off the pavement and into a ditch. To prevent this, something must exert a centripetal force on the car, pushing it firmly toward the center of the curve. If a curved highway were completely flat, the only thing providing that crucial, center-seeking force would be the friction between your rubber tires and the asphalt. But friction is an incredibly unreliable partner. What if it is pouring rain? What if the road is covered in snow, ice, or a dangerous slick of oil? Relying purely on friction for your safety is a recipe for disaster. By banking the curve, civil engineers brilliantly use your car's own mass and momentum to their advantage. The tilted surface of the road pushes back against the bottom of the car at an angle. A significant portion of that push, which we call the normal force, is directed horizontally toward the center of the curve. Suddenly, the geometry of the road itself is providing the centripetal force to steer the car smoothly through the turn, vastly reducing the need for tire friction. You are essentially driving on a very shallow roller coaster without even realizing it. This principle becomes absolutely critical when we move to the realm of high-speed public transportation. Think about modern bullet trains racing across the countryside at hundreds of miles per hour. At those extreme speeds, the forward inertia of the massive train is staggering. If a high-speed train hit a flat curve, the passengers inside would be violently thrown against the side windows, and the train itself would face a catastrophic derailment. To solve this, high-speed rail tracks are heavily banked. As the train leans deeply into the curve, the physics perfectly mirror our swinging water bucket experiment, pressing the passengers safely and comfortably down into their seats, rather than throwing them across the cabin. We also see this elegant physics dance constantly happening in the sky above us. When a commercial airplane needs to turn, the pilot does not just twist a steering wheel to point the nose left or right. Instead, they tilt, or bank, the entire aircraft. By tipping the wings, the massive aerodynamic lift that normally fights gravity to keep the plane in the air is redirected partially sideways. This sideways lift acts as the centripetal force, pulling the massive, heavy airplane into a smooth, graceful arc through the clouds. So, whether you are driving to the grocery store, riding a train to the city, or flying across the ocean, that invisible, center-seeking force is always there, quietly guiding your path. So, the next time you find yourself strapped into a roller coaster, staring up at a seemingly impossible loop, take a deep breath. You do not need to fear the drop or the dizzying inversion. Instead, smile at the beautiful, invisible physics wrapping around you. That thrilling feeling isn't magic. It is the perfect harmony of inertia and centripetal force working together to keep you completely safe. Science isn't just something we study in a textbook. It is the dynamic pulse of the universe, hiding in our theme parks, our daily commutes, and the vast expanse of space. If you enjoyed this wild ride through the laws of motion, make sure to hit that subscribe button and ring the notification bell. You will not want to miss our next grand adventure. We will be leaving Earth behind to investigate profound galactic mysteries, exploring the immense unseen forces that hold our Milky Way together, and diving into the mind-bending gravity of black holes. Until then, keep questioning, keep exploring, and stay curious.